Introducing the Pleur-evac Plus A9250LF and Sahara Plus S1150-08LF continuous reinfusion systems. Both systems are designed to offer the option for collecting and continuously reinfusing autologous blood without a bag. In this video, we will primarily discuss the A9250LF given its prevalence in the market. At the end of this video, we will briefly mention the differences found on the S1150-08LF. The system has two separate compartments in the collection chamber: a large capacity continuous reinfusion compartment and an overflow compartment. Contents within the overflow are not recoverable for reinfusion. The continuous reinfusion compartment contains a 200-micron screen filter and reinfusion tube extending from the back of the collection chamber. Setting up the Pleur-evac Plus A9250 autotransfusion system is a four-step process. The first step is to establish patient protection by applying the water seal by filling the chamber to the 2 cm level. The water seal serves three purposes. First, with its U-tube manometer design, it acts as a one-way valve, allowing evacuation of air from the patient's chest cavity, but preventing its re-entry under normal conditions. Second, utilizing the patented 7-column air leak meter, it monitors the degree of the patient's air leak. Finally, the small arm of the water seal chamber serves as a measuring device for monitoring patient negativity, which is the negative pressure in the patient's pleural space. Now that the water seal has been established, it is safe to connect the patient to the device. The second step in device setup is to connect the 6-foot patient tubing to the patient's chest catheter. Once connected, the patient is now protected from atmospheric air re-entry. The third step in setup, if suction is prescribed, is selecting the level of imposed suction. Both the A9250LF and the S1150-08LF utilize dry suction technology, which means no water is required to operate suction control. A dial is used to set the desired suction level. This is conveniently preset at the -20 centimeters of water setting. If a different level of imposed suction is prescribed, rotate the dial until it clicks into place at the desired level. 5 settings are possible: -10, -15, -20, -30, and -40 centimeters. Finally, connect hospital-supplied suction tubing to the suction port on the Pleur-evac unit and adjust the source suction until the orange float appears in the suction indicator window. This is visual confirmation that the dialed level of suction on the Pleur-evac unit is being attained. Once chest drainage has begun, a regulator within the suction control chamber automatically maintains the prescribed dialed amount of suction on the patient's pleural space. Despite surges in source suction or airflow from a patient air leak, no adjustment is necessary as long as the orange float remains visible within the indicator window. Certain factors may result in lower source airflow, delivering lower than prescribed suction to the patient's pleural space. These factors include, but are not limited to, the age of the suction source, distance from the source, and number of devices connected to the source. For this reason, and thanks to the regulator, suction can be turned up as high as necessary to offset low airflow and actuate the orange float, visually confirming adequate airflow has been achieved. Monitoring of the source to confirm proper function should be a secondary indicator of accurate suction and airflow. When suction is not being used, it is essential to keep the suction tube and port uncapped and unclamped. This allows air to exit freely from the patient, reducing the risk of pneumothorax. On the front of the water seal chamber is a self-sealing diaphragm for adding or withdrawing fluid. Fluid may need to be withdrawn if the water seal is accidentally overfilled or added if fluid in the chamber evaporates over time or in the presence of a large patient air leak. Use a 1.5-inch 18 or higher gauge needle attached to a syringe to add or remove sterile water or saline. Angle the needle downward. If the patient has an air leak, bubbling will appear intermittently with respiration in the patented patient air leak meter. Note the column farthest to the left in which a series of bubbles appears. By observing the furthest bubbling column and notating changes over time, it can be determined whether the air leak is increasing, decreasing, or staying constant. The meter is labeled from low 1 to high 7. The higher the numbered column in which bubbling appears, the greater the degree of air leak. Patency of the patient tubing may be observed as oscillation in the water seal chamber. Oscillations may not be present when the suction is operative, when the lung is expanded, or when the tubing is blocked or kinked. On the top of the unit above the water seal is the positive pressure relief valve. If suction tubing is blocked or occluded in any way, this valve provides a backup for air to exit from the Pleur-evac unit. Patient negativity can be determined by adding the level of imposed suction to the number corresponding with the water level in the water seal. For example, 20 centimeters of water dialed in the suction chamber is added to 5 centimeters of the height of water in the small arm of the water seal chamber. This equals 25 centimeters of water, or the total amount of negative pressure in the patient's chest cavity. There are instances when a patient will develop a high level of negative pressure. This may occur with respiratory distress, coughing, crying, or other factors such as stripping or milking the chest tubes, utilizing an IV pump, or changing from a higher to lower suction setting. When negativity increases, the water will rise in the water seal. If the water rises beyond the 20 centimeter level, the white float ball will rise, impeding the flow of water and preserving the water seal. Although water could rise above the valve, there is a high negativity relief chamber above the valve to contain the water. Regardless of how high the patient negativity rises, water will not spill over into the collection chamber. This relief chamber allows the patient to develop as high a negative pressure as needed for inspiration. However, there are instances when unintentionally imposed high negative pressure rises beyond desired levels and requires manual relief. For example, when using an infusion pump for continuous flow autotransfusion, the infusion pump will create negativity on the water seal as it draws the blood out of the collection chamber. Likewise, when changing prescribed suction level settings from a higher to lower level, patient negativity is likely to remain at the higher level. When these types of unintentional high negativity occur, the negativity can be reduced by depressing the manual filtered high negativity relief valve. For example, when turning the dial from a higher to a lower suction level setting, the water in the water seal will rise, indicating the patient's negative pressure remains at their originally imposed level, unless the patient has an air leak. To manually adjust the negativity to the new setting, depress the manual filtered high negativity relief valve. Observe the water level in the water seal chamber drop until it reaches the desired level, being sure not to let it drop below 0. By depressing the valve, filtered air enters the unit. Now the patient negativity is at the new lower level as set on the suction control dial. The high negativity relief valve can be used anytime to manually vent excess negativity. Note that if suction is not operative or the patient is on gravity drainage, depressing this valve can reduce negative pressure to 0 or atmosphere, with a resulting possibility of a pneumothorax. At the junction where the 6-foot patient tube connects to the collection chamber, anti-kink tubing is incorporated to eliminate any unnecessary metal springs or other materials being in the critical blood flow pathway. Just beyond the anti-kink tubing is a pair of red and blue locking connectors, which allow for quick disconnection and reconnection to a new chest drainage unit when necessary. A needleless sampling port is located at the junction, allowing specimens of patient drainage to be taken whenever needed. Use only a standard Luer lock syringe to withdraw samples from the autotransfusion connector. No needle is required. The collection chamber of the A9250LF is calibrated in 2 milliliter increments up to 50 milliliters, in 5 milliliter increments up to 200 milliliters, and 10 milliliter increments up to 2,100 milliliters. Only contents within the first collection chamber can be used for reinfusion. A 200 micron screen filter is contained within this chamber. Its purpose is to trap any clots or debris coming from the chest cavity while allowing maximum blood flow through the unit. When the fluid in the collection chamber exceeds 1,000 milliliters, the fluid will spill over into the second collection chamber. Blood cannot be recovered from the second chamber. It functions solely as a collection chamber. When drainage reaches 2,100 milliliters, the unit is filled to capacity and must be replaced. Note: collected autologous blood should be reinfused within 6 hours from the initiation of collection. To begin continuous reinfusion of autologous blood with the Pleur-evac A9250LF or S1150-08LF, start by setting up a blood-compatible IV pump. Obtain a microaggregate filter and an administration set for use with that pump. Prepare the reinfusion tubing for connection to the microaggregate filter and administration set. Be sure that the clamp on the Pleur-evac reinfusion tubing is open and the tethered exit port cap is closed. Hold the tubing below the bottom of the Pleur-evac device and gently milk it until it's filled with blood and free of air. Now, close the clamp to temporarily stop blood flow. If the pump requires pre-priming of the microaggregate filter and administration set with saline, do so per the manufacturer's guidelines. Remove the tethered cap from the exit port of the tubing and spike it with the saline-primed microaggregate filter and administration set. Open the reinfusion tubing clamp. The A9250LF contains a tubing placement strap at the top of the anti-kink tubing. Using the provided strap, position the reinfusion line, ensuring the microaggregate filter is in a spike-up orientation. Reconfirm the infusion line is filled with blood and free of air prior to beginning reinfusion. If the infusion pump does not require pre-priming with saline, priming will be done with blood following milking of the reinfusion tubing, as previously discussed. With the clamp in the closed position, remove the tethered cap from the exit port of the reinfusion tubing and spike it with the microaggregate filter and administration set. The set should be positioned in a spike-up orientation to allow for priming with blood. The clamp should now be reopened. Finally, you will begin priming the microaggregate filter and administration set with blood using the IV pump or a 60 cc syringe and stopcock. Using the provided strap, position the reinfusion line, ensuring the microaggregate filter is in a spike-up orientation. Reconfirm the infusion line is filled with blood and free of air prior to beginning reinfusion. Connect the infusion line to the patient's catheter. Finally, after attaching the infusion line to the patient's catheter, set the infusion rate as prescribed. If necessary, as previously mentioned, the manual filtered high-negativity relief valve may need to be depressed to offset excessive negativity buildup caused by the IV pump. Note that during continuous flow autotransfusion, the fluid in the collection chamber must never fall below 50 milliliters. Eventually, you may decide to discontinue reinfusion therapy and use the device as a simple chest drainage collection unit. When disconnecting from the infusion pump to discontinue continuous reinfusion, be sure the clamp on the reinfusion tubing is in the closed position and the tethered cap of the exit port is in place. Summarized features of the A9250LF include dry suction technology with suction regulator and visual float indicator, wet seal technology with air leak diagnostics, tip-over protection when suction is operative, automatic positive and negative pressure relief valves, manual high negativity relief valve, quick disconnect tubing with needleless sample port, and 1,000 milliliter reinfusion collection chamber capacity. The S1150-08LF contains similar features to the A9250LF with a few notable differences. Similarities include dry suction technology with suction regulator and visual float indicator, automatic positive and negative pressure relief valves, manual high negativity relief valve, and quick disconnect tubing with needleless sample port. Notable differences include Dry one-way seal ensures patient is protected from atmosphere as soon as connected. Tip-over protection at all times. Negative pressure indicator, yes, indicates presence of negativity in the collection chamber. And 1,050 milliliter Reinfusion collection chamber capacity. This concludes our continuous Reinfusion setup training. Thank you for participating. See more education materials at Pleur-evac education.com.